Dear students, welcome to my class. In this video, I am going to discuss Cramer's rule in order to solve a system of linear equations, and Cramer's rule also known as method of determinants. So let's consider a system of linear equation like this. And what is a system of linear equation? More than one linear equation is a system of linear equation. Here we have two linear equations. So let us solve this system by Cramer's rule. And to do that, first you need to know some basics about matrix, because in order to solve this system, first you need to know what is coefficient matrix. So the coefficients of x and y we can write in matrix form. This system of linear equation we can write in this way, which is equal, this is a column matrix C1 C2. So this matrix let us denote by A, and this column matrix let us denote by X. The column matrix in the right side let us denote by B. So here A is called coefficient matrix. Coefficient matrix, since the components of A are the coefficients of x and y. The first column in this matrix is the coefficients of x, and second column in this matrix is the coefficients of y. So since these components are the coefficients of x and y, that's why matrix A is called coefficient matrix. So since I use matrix, first you need to know what is a matrix. We know a matrix is a rectangular array of numbers. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 2, 5. So this is a matrix. So what is the definition of matrix? A matrix is a rectangular array of numbers. Why it is rectangular array? Because the length is 4 units and the width is 3 units. So it forms a rectangle. That's why this arrangement is called rectangular arrangement. But let's say, for example, this 0 is missing here. In that case, it is not a rectangle, you see. Then the arrangement is an octal arrangement. You see, 1, 2, 3, 4, 5, 6, 7, 8. So this arrangement is no longer be a rectangular arrangement, and in that case, this is not a matrix. Again, let me put 0 here. So now it is a matrix. And the entries, these are called the entries of matrix. 1, 2, 3, 4. These are the entries or members or elements of a matrix. And matrices are denoted by English block letters. Let's say A equal to this. So here A is a matrix having how many components? 3. There are how many rows? 3 rows. These are called rows. First row, second row, and third row. There are 3 rows. And how many columns? 4 columns. First column, second column, third column, and fourth column. So you can write 3 cross 4 here, but read as 3 by 4, 3 by 4, and which indicates the order of this matrix. A is a matrix of order 3 by 4, where 3 indicates number of rows and 4 indicates number of columns. So I say this is the order or size or dimension. So A is a matrix of order 3 by 4 or size 3 by 4, or A is a matrix of dimension 3 by 4. Now what is a square matrix? Because we can calculate determinants only of a square matrix. So a square matrix is a matrix which has equal number of rows and columns. For example, let's say B equal 1, 2, 3, 4. It has 2 rows and 2 columns. It is a 2 by 2 matrix. Therefore B is a square matrix. And let's say another one, C, which is the first row 1, 0, 5, second row 7, 8, 9, and third row 5, 4, 6. So if you enclose those numbers within first bracket or third bracket, then it is called a matrix. And the order of this matrix is 3 by 3. Therefore it is a square matrix. Now you can determinant only of a square matrix, and determinant of a matrix is the value of that matrix. What is determinant? For example, let me first define the determinant of a matrix. Let's say A is a square matrix, first row AB and second row CD. So the determinant of A we can denote by det of A. This is the determinant of A. Or if you put A within 2 vertical lines, then this symbol also known as determinant of A. And definition is determinant of A equal AD minus BC. You need to multiply A and D, then minus B into C. For example, if A is a matrix, or let's say B is a matrix of, then what will be the determinant of B? Determinant of B is equal 1 into 7 minus 5 into 9, which is equal 7 minus 45, and this equal minus 38. So the determinant of B is equal minus 38. So now let us define determinant of a 3 by 3 matrix. And determinant of A will be what? In order to find the determinant of A, you need to work following either first row or second row or third row, or first column or second column and third column. Any one is fine. You can work either first row or second row or third row, or following first column, second column and third column. There are 6 options. You can do any one. Let us follow first row. So it means you need to do some work with A and B and C. And when you are working with A, the preceding sign of A will be plus. And you need to multiply A by a submatrix. Then the sign of B will be negative. The preceding sign of B will be minus, and preceding sign of C will be again plus. So the sign will be alternating plus and minus, starting with a plus sign. And why it is plus and minus? Because it depends on this minus 1 to the power I plus j. I indicates row and J indicates column where the entry is located. For example, A is located in the first row, first column. So the preceding sign of A will be minus 1 to the power first row plus first column, which is minus 1 to the power 2, which is plus. And for B, I equal first row and J equal to, J means second column, so 1 plus 2, which is equal minus 1 to the power 3, which is equal minus 1. And for the case of C, C is located in the first row, third column, so 1 plus 3, which is equal again plus 1. Therefore, the preceding sign of A is plus, preceding sign of B minus, preceding sign of C plus. And what will be here? The submatrix. You need to eliminate the corresponding row and column where A is located. Since you are working with A, then A is located in the first row and first column. So if you eliminate the first row, first column, the submatrix, remaining matrix will come here, Mn. And when you are working with B, you need to delete second column and first row. The submatrix will be D, F, H, N. And when you are working with C, third column and first row, you need to eliminate. The remaining part is D, E, H, M. So this equal A into En minus Mf minus B times Dn minus Hf plus C times Dm minus He. So this is the definition of determinant of a 3 by 3 matrix. Now we are able to solve a system of linear equation by Cramer's rule. So let us solve this system. A1 x plus b1 y equal c1 and a2 x plus b2 y equal c2. Now here I said the coefficient matrix A, which is A1, B1, A2, B2 times x, y is equal C1, C2. So the Cramer's rule, let me first define the Cramer's rule. Cramer's rule indicates that the solution of this system will be what? X equal d suffix x divided by d, and here d should not be 0, d must be non-zero, and y equal dy by d. So this is the Cramer's rule, where d indicates, d is what? D is the determinant of coefficient matrix. If this matrix is A, then determinant of A is D, which is equal determinant of A1, B1, A2, B2. This is D. And what is dx? Dx is determinant of coefficient matrix, but in the coefficient matrix, the x coefficients will be replaced by the right hand side, by this column. When you are calculating x, in the dx, the x coefficients in the coefficient matrix, x coefficients will be replaced by C1, C2. It means A1 will replace by C1 and A2 will replace by C2, and the second column will remain same, B1 B2. And in the case of dy, y coefficients will replace by C1 C2, but the first column will be same. First column was A1 A2. So if you can determine the dx and dy, then you can easily calculate the solution of this system, which is this: x equal dx by d, y equal dy by d, where d should not be 0. And if it is a three-dimensional case, three-variable case, a system of linear equation in three variables, then z will be dz by d. So now we understand Cramer's rule, and we can solve a system of linear equation by Cramer's rule. Let us try this one. Here D coefficient matrix is 1 1 and 2 minus 6. 1 1 2 minus 6. Determinant of 1 1 2 minus 6. 1 into minus 6, which is minus 6, minus 2 into 1, which is 2. So it is minus 8, and which is not 0. When D equals 0, if D equals 0, then the system has no unique solution. For that, when determinant of coefficient matrix equal to 0, then what will be your answer? The system has no unique solution. This unique word is very, very important in this case, because the system may have infinitely many solutions. But when D equal to 0, the system has no unique solution. So here D equal minus 8, and dx will be what? Right hand side 11 and 0. So x coefficients will replace by 11 0. It means first column will replace by 11 0, and the determinant is 11 into minus 6 minus 0 into 1 0, which is minus 66. And for the dy, y coefficients, it means second column in the coefficient matrix, will replace by 11 0, and the determinant is minus 22. So x equal dx by d, dx equal minus 66, and d equal minus 8. So the solution is this. This is the value of x. And similarly, y equal dy by d, which is 11 by 4. So the solution of the given system is x equal 33 by 4 and y equal 11 by 4. Now if it is a 3 by 3 matrix, I mean if it is a system of three linear equations in three variables, then coefficient matrix will be 3 by 3 matrix. And the determinant we will calculate following this definition. So the determinant of coefficient matrix D here will be 1 into 1 minus 1, which is this, and minus 1 into 1 into minus 2, minus 1 minus 2, which is this, and 1 into 1 plus 2. So the value of D is 6, which is not 0. It indicates that the system has a unique solution. And similarly, dx we can calculate in this way. In the dx, x coefficients means first column. This column will replace by 6 2 1, and the remaining two columns will be exactly same, 61. In the dy, second column will replace by 6 2 1. In the dz, third column will replace by 6 2 1, and dx is equal to 6 dy 12, dz 18. Therefore x equal dx by d, dx 6 and d also 6. So 6 by 6 equal to 1. Y equal dy by 6, which is 2, and z equal dz by 6, which is 3. So the solution of the given system by Cramer's rule we have calculated here, which is 1, 2, 3. And let us try this one. Here your d is equal determinant of here you have how many variables? 3 variables, x1, x2 and x3. But in the first equation you see x3 is absent, which indicates that the coefficient of x3 will be 0, because first equation we can write 2x1 minus x2 plus 0 into x3, which is equal to 2. So the first row will be 2 minus 1, 0. And similarly in the second equation x1 is absent, so the coefficient of x1 will be 0 and coefficient of x2 3, coefficient of x3 2. In the third equation x2 absent, therefore coefficient of x2 will be 0, coefficient of x1 5 and coefficient of x3 3. And let us calculate the determinant of coefficient matrix, which is 2 into determinant of this submatrix, which is 9 minus 0. You can directly write 9 minus 0. Now minus, if it is negative 1, then it will be positive 1, because in this case you have negative sign in the definition. In the definition you have negative sign before b, and here b equal negative 1, so it will be plus 1. So the submatrix will be what? 0, 2, 5, 3. 0 into 3, 0 minus 5 into 2, which is 10, plus if your third component is 0 in the first row, so you don't need to do any work with 0, because 0 times any number will be equal to 0. So this equal 2 into 9 minus 10, which is equal 8. So the determinant of coefficient matrix is equal to 8. Now let us calculate dx. The first column will replace by the right hand side, which is 2, 16, 21. 2, 16, 21, and second column will be same, minus 1, 3, 0. Third column will be exactly same, 0, 2 and 3, and this equal 2 into 9 minus 0 like before. This is the submatrix, this one, 9 minus 0 plus 1 times 3 into 16, which is 48, minus 21 into 2, which is 42, plus 0, this equal 18, plus 48 minus 42, which is 6, this equal 24, dx 24, and dy is equal determinant of second column. First column will be exactly same, 2, 0, 5, and second column will replace by 2, 16, 21, 2, 16, 21, and third column will be exactly same, 0, 2, 3, and this equal 2 into, let us follow first row, so 2 into 16 into 3, which is 48, minus 2 into 21, 42, minus 2 into the sign of the preceding sign of this 2 will be minus. So minus 2 into 0 into 3, which is 0, minus 5 into 2, 10, plus 0, which is equal 2 into 6, minus 2 into minus 10, which is equal 12 plus 20, and this equal 32. So dy 32 and dz will be equal to, the first column will be exactly same, 2, 0, 5, and second column will be minus 1, 3, 0, minus 1, 3, 0, exactly same, but third column in the coefficient matrix will be replaced by 2, 16, 21, 2, 16, 21. Now the determinant will be 2 into 3 into 21, 62, 63, minus 0 into 16, which is 0, plus 1. The sign, this minus 1 will be plus 1, and 0 into 21, which is 0, minus 5 into 16, which is 80, plus 2 into 0 into 0, minus 3 into 5, 0 minus 15, which is equal 2 into 63, minus 80, minus 30, which is equal 126, minus 110, which is equal 16. So the x will be dx by d, and here dx equal 24 and d8, dx 24, d8. Therefore x will be 24 by 8, which is 3, and y will be dy 32, 32 by 8, which is 4, and z equal dz, which is 16 by 8, which is 2. So the solution is this, x equal to 2, sorry, the solution is this, x1 is equal 3, x2 4, and x3 2. But here I used xyz instead of xyz. I should use x1, since the variables are x1, x2, x3. So instead of dx it should be dx1, instead of dy it should be dx2, it should be dx3. Now the solution will be x1, x2, and x3. x1 equal to 3, x2 4, and x3 2. This is the solution. And similarly you can try to solve this one by yourself. The solution will be 2, 3, and -1. And there are also 3 problems. This one, the solution of this one you can try in your apartment, that will be this, and solution of this problem will be this, 5 minus 6, 7. Solution of this problem will be this, 2, 0, and 3. So please note that again, by using Cramer's rule we can calculate unique solution of a system of linear equation, unique or single solution. or one solution. When a system has unique solution or single solution or one solution, that we can calculate by Cramer's rule. However, when a system has infinitely many solutions, we cannot calculate. But when d equal to 0, we can say that the system has no unique solution. No unique solution or no single solution. It can have infinitely many solutions. That's all for today's class. Hope to find you in the next class. Thank you very much for your listening.